Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about computational chemistry. You know my friends, first we have to define computational chemistry. So computational chemistry is a branch of chemistry that uses computer simulation to assist in solving chemical problems. Clear to you? Branch of chemistry that uses computer simulations means you should know little bit about the computer. So computer simulation to assist in solving chemical problem. What is the chemical problem? I will discuss later on. It uses method of theoretical chemistry incorporated into efficient computer programs to calculate the structure and properties of molecules. If we are talking chemistry, so you have the chemical formula, means you have the structure and what is the properties of that structure. Why we are focusing on a structure? Because if a structure changes, then automatically all properties will change. The results obtained from computations are complement information obtained by chemical experiments. Whatever you are getting the results, you can apply, you can think, and you have to perform according to results we got through the computational methods in the laboratory. It can be used for drug design. It is uses of the laws of quantum mechanics, classical mechanics, or a combination of them to solve the problems. Sometimes two theory you need to explain. So choosing the right method for the calculation depends on the type and magnitude of the case and also the type information that is required. Now, my friends, computational chemistry methods. These are methods. I am going to read one by one. You have to think about it. You have to think about it. First, ab initio. And you have to learn about it. What does it mean? Why ab initio? What is the difference between ab initio and density function theory? Such type of question at initial level you can create in your mind and increase your interest toward the computational chemistry. So you have the second density function theory. You have semi-empirical and empirical. You have the molecular mechanics. You have the method for solid. You have chemical dynamics. You have molecular dynamics. These are the computational chemistry methods. So I am going to directly computer simulations, because when you are talking about the simulations, you are talking about some software. So I will discuss about the software packages. There are many self-sufficient software packages used by computational chemists. Some includes many methods covering a wide range, while other concentrating on a very specific range or even a single method. So biomolecular modeling program, protein, nucleic acid. You have the molecular mechanics program, quantum chemistry and solid state physics software supporting several methods, molecular design software, semi-empirical programs, and valence bond programs. So we have a lot of different software packages, different directions of research in different field. Why are computational chemistry method used? This is the questions, and these questions always in the beginner minds, why and what we are getting from the computational chemistry. So why are computational chemistry method used? They are simple method. They are less expensive than empirical methods. The reaction can be performed under certain conditions. They are safe. They are used when there isn't any experimental model for the system, or if are existed but is hard to access or create the conditions. What does it mean? If somebody told you you can synthesize cis or trans two compounds, then how you synthesize these two compounds? Definitely you will go through the literature survey. You will take the experimental methods, write it down in your notebook, then you will perform the experiment in the laboratory. But if you have no any literatures, what will happen? Then it will be very easy. You have to draw these two structure, and if you have the any package, you can calculate, and you will get the some important informations regarding these two molecules. Anyhow, based on computing software, first based on quantum mechanics, second based on molecular mechanics. What does it mean? Quantum mechanics solving the Schrödinger equations, and molecular mechanics Newton's law or classical physics. For a small system, and Newton's for very large system, such as a particle system, example electron, and such as proton with 80,000 atoms. So quantum mechanics is more accurate. Quantum mechanics is more accurate. Here TA. Quantum mechanics is more accurate. Now approximation method. We are not approaching exact method. Approximation methods. So we have the ab initio method, we have semi-empirical methods, we have density function theory methods. So ab initio method is completely based on quantum mechanics principles. Approximations are done only for mathematical forms. So we have a mathematics for the calculations of approximation. You know the semi-empirical methods, these methods are similar to that of ab initio, but the results are fitted to experimentally determine parameterizations. I will later talk on what is the meaning of parameterization here. Now, density function theory method to determine the energy of molecules in considered electron density rather than electron wave functions. And this method requires lesser computational power than that of ab initio method. This is the difference. So read it properly, write it down, and think about this chemistry. Post HF method. What does it mean? What is the meaning of HF? Hot reform. This is the term. Always focus on term and keep in your mind. MP2. What does it mean? Similar to DFT in total accuracy. Describe all kind of correlation energy. Now you have learned about the energy. Here correlated energy, correlation energy. So many more methods like MP3, MP4, QC, ISD, BD, CC, SDT, like that. So, density function theory, take into consideration the electron density. This is very important. So, density function theory, you know, my friends, increasing quality and computational cost. If you have the methods at bottom, highly cost. VWN5, BLYP, SCTH, BP86C, 86, TPSS, B3LYP, B97, /2, MPW1K, MPWB1K, MO5-2X, MO6-2X. These are actually the methods. Computational cost will increase. So, density function theory, what is the advantage? Does not depend on experimental data. Small system requiring high accuracy. What is disadvantages? Because everything has some advantages and some disadvantages. So you should know the first disadvantages, then advantages. What is disadvantage of this theory? There are difficulties in using density function theory to properly describe intermolecular interactions, especially van der Waals forces, dispersion, charge transfer excitation, transition state, global potential energy surfaces, and some other strongly correlated systems. So my friends, modeling method for molecules. What is the meaning of this? You can see this graph have the number of atoms and accuracy. If number of atoms increases, then you are moving to different theory. If you have 1 to 10, 10 to 100, 100 to 1000, 1000 to 10,000, like that, you can see the accuracy is decreasing. You have the CCST, MP2, DFT, Hartree-Fock, quantum mechanics and molecular mechanics, semi-empirical methods and molecular mechanics, you can see. So I am going to introduce one package, that is Gaussian 19 for Windows, Linux, Unix, Intel, Mac. You know, my friend, Gaussian is a computer program for computational chemistry, initially released in 1970 by John Poppel and his research group at Carnegie Mellon University as a Gaussian 70. Now, Gaussian is capable of predicting many properties of molecules and reactions, molecular energies and structure, bound and reaction energy, IR, NMR, Raman, UV visibles, and reaction pathways. So, what is the advantage of this software? Produce results that match closely with the experimental data. And this is very important here. If your data is not matching, you have to go to the higher methods. Under Windows and Linux, which are commonly people using this, quicker than numericals model, do not require supercomputers, molecules in their ground and excited state can be calculated. So I already told you, always some methods have the disadvantage. So computations can be carried out on molecule in the gas phase or in solution, not in solid. This is the limitations. Now my friends, Gaussian calculation are best prepared using the Gauss-View interface. What does it mean? You will understand after 2 and 3 slides. Gauss-View allow you to build the required molecules on your screen, and using menu pull downs you can load the file into the Gaussian program for execution. After the Gaussian run has completed, you can view the complete .log file. That is very important. You should know your result file, .log file, written by Gaussian, and also you can use the binary .chk file or check file to generate various graphical surfaces. Now look at here, the blue empty window, new is the builder window where you can see the molecule is built. Did you see? So double click on the desktop icon, start the program. You will see like this window. Now to build a toluene, how you will build a toluene? Click on the benzene ring icon on the main window. Place the cursor in the builder window and click. A benzene ring will appear as shown below. Did you see the benzene ring? Now, then click on the atom type icon in the main window, carbon. So, periodic table will appear. So, click on carbon and select the tetrahedral atom type. Now, click on hydrogen atom of benzene ring in the builder menu and the toluene molecule should be built. Look at here. Now, you now can change the molecular display properties by going to View menu and select Display Format. So, a variety of format, ball and bond, wireframe and tube are available. Choose tube and note change in display window. Click OK to save the display change. Look at here. So calculate using Gaussian program as setup and run using calculate menu. Upon opening, the following is displayed. You can see. This allows various type of electronic structure calculation to be performed using Gaussian. Now friend, what is important here? Geometry optimization, first work. Geometry optimization is a name for the procedure that attempt to find the configuration of minimum energy of the molecule. The procedure calculates the wave function and energy at a starting geometry and then proceed to search a new geometry of a lower energy. This is repeated until the lowest energy geometry is formed. So, energy optimization or geometry optimization will take more time. Now, my friend, frequency and thermochemistry. Calculate the vibrations of molecule in questions along with other parameters that you can choose to include or erase from the output. So because the molecular frequency depends on the second derivative of energy with respect to the molecular nuclear position, you should make sure that the theoretical models you choose for the calculations compute section derivatives, ab initio and DFT theoreticals, and best result based on the experimental value. So you can see, for an example, choose energy under job type. Go to job type and choose energy, submit. Note one can also choose a variety of other jobs such as geometry optimization, vibrational frequency analysis. Under the method submenu, we can choose the type of calculations we wish to perform. Play it, this software you can play it. This can be heretofore with or without some form of electron correlation treatment, semi-empirical, that is MP3 or AM1, or a density function theory, calculations using a appropriate density function, either local, gradient, correlated, corrected or hybrid type. So look at here. Now for Hartree-Fock or density function theory calculation, we also have the opportunity of choosing an appropriate basis set. Appropriate basis set, keep in your mind, basis set very important for this calculation. What basis set we are using for your calculations? So basis set from a submenu. For our examples calculations, we will choose the Hartree-Fock method with the STOG basis set. Now the question is, what is the meaning of STO and G? You will learn later. You submit our calculations. We submit our calculation using submit button. You are asked for a file name to save the job. Choose an appropriate instructive name, Tallinn HF3G, save the file and continue with the submission. Any window will open where the program of run can be monitored. Now, the output data is written to two types of result file: a log file, which is a text listing of the program's steps, and a check file, which is binary file that can be used to generate various surface representation. So choose the .log file first, and the Tallinn molecules will appear in any window. So to view the log file, go to the results menu and choose view file. Now a window containing the file listing should appear. A WordPad text file. Scroll down through the file to see the information content. You can see the results. So displaying molecular orbital, electron density and electrostatic potential. My friend, build the para-methyl phenol molecule. Modify the molecule such that the OH groups lies in the ring plane. This can be done using the dihedral angles modifier shown highlighted in the figure below. You can see it is highlighted to change the dihedral angles. For graphical presentations of orbital and electron density, the checkpoint file is required. Using the calculate menu, we need to save a copy of checkpoint file in your working directory. We do this by opening the link 0 menu in the setup box and clicking the checkpoint file box. You can see here. So by clicking the check file and appropriate name, we can retain it in our working directory after job runs for analysis. Here working directory means where you have saved your all data. Use the file open combination to obtain this using check filter. Open the Chrysos check file, save the U in your working directory. Molecules appears in the separate window. To examine the orbital energy level and orbital electron density, use edit molecular orbitals. So look at here. This is the another window where up and down two electrons, one is HOMO and LUMO. So an orbital energy level diagram is produced and occupies 1 to 21 in this case, and unoccupied orbital are present. The HOMO is molecular orbital 21 and the LUMO is molecular orbital 22. Very important point, you have to write it down in your notebook. So to get an electron density surface for any orbital, simply click on the orbital or combinations of orbitals and highlight them. So this is shown for the HOMO and LUMO below. This is the yellow one which is highlighted. Now select visualize followed by update from the surface window, display, and after a few seconds an electron density contour of the HOMO and LUMO orbital will be displayed. Look at here. So To display other graphical surface, the results surfaces menu must be chosen from the main Gaussian window. So an electron density contour plot can be obtained as shown below. So you can see after summation the electron density plot is available in the cubes available. Under surface action choose new surface. An electron density plot will be displayed in a few seconds. Look at here. So the display is a contour of electron density at a chosen value. This can be changed to any desired value by typing the value in the ISO value for new surface text box. Look at here. So the skin-like nature of representation is demonstrated by introducing Z clipping. This is performed by right button clicking in the display window, selecting display format, and then in the resulting new window selecting surfaces. Moving the Z clip side enables the interior of the display to be shown as demonstrated below. You can see here. So another useful graphical display is a mapped surface. Mapped surface, my friend, here just write it down. Here two properties can be displayed at the same time, providing additional information. A total electron density surface, the electrostatic potential. We first calculate the total electron density default contours and map the electrostatic potential onto this surface. I repeat, we first calculate the total electron density default contour and map the electrostatic potential onto this surface. So harmonic vibration frequency. Harmonic vibration frequency calculations are also set up via the calculate menu. It is essential to perform the vibrational analysis using exact same method that you have used to perform prior geometry optimization. My friend, we could perform the vibration analysis directly so long as we use the same calculation method AM1. Often it is best to perform the geometry optimization and vibration analysis in the same run, and this can be done most conveniently using the opt plus freq job types in the calculate box. So alternatively, the vibrational data can be displayed from the main Gaussian view Gauss view window using the results vibrations menu combinations. Now the vibrational frequency of all three modes and infrared and Raman intensity are given. Each vibrational mode can be animated by highlighting the mode and clicking the start button. Look at here the water molecules. In addition, the calculated infrared and Raman spectra can be calculated and displayed by clicking on the spectrum button. Then you will get the frequency, infrared, Raman activity, and further dipolar. So in addition, displacement vectors can be displayed by highlighting the show displacement vector button as shown above. You can see. So my friends, this is in RB. So G09 input consists of the following parts: percentage sections, root sections, title section, charge and multiplicity, CM we generally seeing, and then you can see the items. So the first line specifies the path to the file you just loaded, and then section specifies the name of the checkpoint file, and then root sections specify the basis set, the theoretical model, and the type of job you want to perform. Title section specifies the name of the job for users easy only. The charge multiplicity specifies the charge and spin multiplicity of the current. So you can see the processing complete. You have a lot of informations here. So what information do you get out of these calculations? I am going to read one by one and write it down. Atomic coordinates of optimized molecules. First, atomic coordinates of optimized molecule. Second, optimized parameter, atomic distance and angle. Third, homo-LUMO eigenvalues, heart rate. Mulliken's atomic charges, short. Dipole moments, single point energy, harmonic frequency, wave number, reduced mass, AME, force constants, IR intensities, Raman intensities, not default, thermochemistry, temperature, pressure, isotopes used, molecular mass, thermal energy, constant volume, molar heat capacity, and entropy. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.